Question 4. A student wants to calculate the density of two objects shown in the figure below. We have a metal cube with two sides both being 10 centimeters. Since it's a cube, we can assume that the third side is also 10 centimeters. And we have a small statue. We have no dimensions regarding the statue. Question A. Each side of the metal cube measures 10 centimeters. The metal cube has a mass of 0.2 kilograms. Calculate its density in kilograms per meter cubed. Now, to find the density, we must always start from the equation, which I will remind you, rho is equal to mass divided by volume. Density is equal to mass divided by volume. Now, we do have a value of mass, which is 0.2, but the volume we have to find. I will also remind you that the volume is found using the equation volume equals length times breadth times height. However, we have a bit of a problem, because we have been told that the value for density that the examiner wants is in kilograms per meters cubed, but the dimensions we have been given of the metal cube are in centimeters. So we have to either convert the 10 centimeters into meters and then work out the volume, and after we work the density. Or else, we can work out the volume using 10 centimeters, find the answer in centimeters cubed, and then convert it to meters cubed, and finally calculating the density. So I will be working it out using both systems. So let's split the area in two. So 10 centimeters equals 0.1 meters. So the volume is going to be 0.1 times 0.1 times 0.1, which will give us 0.001 meters cubed. Plugging this value into the original equation, we get density is equal to 0.2, the mass in kilograms, divided by 0.001, which will give us an answer of 200 kilograms per meter cubed. Now let's work it out without converting the 10 centimeters into meters. So once again, we have to start with finding the volume, which length times breadth times height will give us 10 times 10 times 10. However, we cannot work out with centimeters cubed. We have to convert this into meters cubed. And as you should remember from our first few lessons, to convert from centimeters cubed to meters cubed, we have to divide by 100 cubed, which will also give us 0.01 meters cubed. The last step will be the same. So the density is going to be equal to 0.2 divided by 0.001, which will give us 200 kilograms per meter cubed. And we have the same answer for both methods. Obviously, in an exam, you do not have to work both methods. You just pick one and use that. I personally prefer converting the units before I start, because I think it is easier to remember converting centimeters into meters than it is converting centimeters cubed into meters cubed. But it is all down to preference. Moving on to question B. The student then wants to work out the density of the small statue. Describe the method the student should use to calculate the density of the small statue. Now, to be able to find the density, we must first find the mass and the volume. So let's start from the mass. We find the mass by placing the statue on an electronic balance. So the first step is going to be the mass is found by placing the statue on an electronic balance. Now, to find the volume, since it is not a regular shape, then we cannot simply work out volume equals length times breadth times height, nor can we measure any readings. Instead, we have to use the displacement method by either using a displacement can or else using a measuring cylinder that the statue can fit in. And since we've been told that the statue is small, then we can use a measuring cylinder. So the first step in finding the volume would be a measuring cylinder is filled with water and its reading V1 recorded. Next, the statue is gently lowered into the measuring cylinder And the second reading, V2, is also recorded. Once we have both values, we simply find the difference, and that will give us the volume. So the volume of the statue is found by finding the difference between the values, V2 minus V1. Finally, since we now have a reading for the mass and a reading for the volume, we can measure the density. So the density is found by dividing the value for mass by the value of the volume, according to ρ equals m divided by v. And that is the answer for part B of question 4.